Hello students, welcome to Akshar IIT Foundation classes. This is Ghaffar Mohammed, your physics faculty. Let's start our session. In the last class, we completed about the dimensions. Okay, today also we related to the same kind. So let's start that. So already I explained that fundamental quantities. Okay, so and also I explained that derived quantities. Now, what are these dimensions and dimension formulas? These dimensions and dimension formulas nothing but expressing any physical quantity in terms of fundamental quantity is known as dimensions and dimension formula. That is called dimensional analysis. So let's see how to write dimension formulas and how to know dimensions of physical quantity and how to find dimensional equations. So here 3 points specifically we need to emphasize. One is dimension formula, second one is dimensions, third one is dimensional equation. But what is these all are? These all are nothing but expressing any physical quantity in terms of fundamental quantity is known as dimensional analysis. Got children? Let's let's write first of all fundamental quantities. You know fundamental quantities how many are there? So now first let me write first here first physical quantity is mass, second one is length, mass, length, time, fourth one is temperature, fifth one is amount of substance, sixth one is current, seventh one is luminous intensity, So these 7 are called fundamental quantities. Understand? In the physics science part, we only having fundamental quantities. How many? Only these 7. Now, what is mean by dimensional analysis, children? Here, dimensional analysis nothing but writing any quantity, either it is derived or it is fundamental, in terms of fundamental quantity is known as dimensional analysis. And it is dimensional analysis. We have terms like dimensions, dimensional formula, and dimensional equation. This you can understand by taking an example. Directly you can't understand properly. By using an example, we can explain clearly about this dimensional equations, dimensional formulas, and dimensional analysis. So I'll take the example. You know the best example explaining for this dimensional equation or dimensional analysis is small quantities you must take. You know very well known quantity, you know that area is a quantity, physical quantity, because it has a units, right? So I'm taking that here, I'm taking the area. So here I'm taking the area. Here area is a physical quantity. When it has a physical quantity, to find that, actually area is a derived quantity, isn't it? Derived quantity means you can get this derived quantity by fundamental quantities. But what are the fundamental quantities involved here? The involved fundamental quantities are length into breadth. So here finally what is the conclusion? The area formula is length into breadth, as well as units are meter square. units are meter square, because here length units meter and this breadth units also meter. So combinedly the area units become meter square. It is a SI unit. Understand, children? Now let us write this area in terms of fundamental quantity. That is our intention. Now, so every time whenever you are writing dimensional formula or dimensionals, you must show the physical quantities in the square bracket. So I am showing here, I am taking example here, area is an example. So I am taking area in a square bracket. So that is a area, and here area. So I wish to write this area in terms of fundamental quantities. So the fundamental area, length into length into breadth. This is length, this is length. So here mass contribution is 0, length contribution is 2, time contribution is 0. So this is your dimensional formula or dimensional analysis. Writing this way is nothing but dimensional analysis, and writing this way is called dimension formula. Look at here, in this, just look at here carefully. Here this total complete equation is called dimensional equation. This complete equation is called what? Dimensional equation. And here only this part is known as dimensional formula. And here one more important thing is the powers raised for the fundamental quantities. The powers raised for the fundamental quantities are known as dimensions. These powers are called powers raised for fundamental quantities. Fundamental quantities is known as dimensions. Understand? The powers raised in the dimensional formula, okay, of the fundamental quantities is known as what? What kind powers? Powers are nothing but dimensions. So this is the way we can express dimensional equation, dimension formula, as well as dimensions. I hope you got clarity. So let me give one more example such that you will get more clarity here. I'll give one more thing. For that, I'll take one more easiest quantity. I will take one more easiest quantity is volume. Understand, children? Volume is one more easiest quantity. I'm taking one more equation here, volume. So volume, you know volume formula, length into breadth into height. Length into breadth into height. Length into breadth into height is a volume formula. Now when the volume formula is length into breadth into height, what is the units? Yes, you are right, the units are meter cube, because length is meter, breadth is meter, h also meter, so totally meter cube. So that way simply we can write the formulas by using the, you can write the units by using the formulas. Now children see here, now we want to write dimensional formula, dimensional equations. This physical quantity you need to express in terms of dimensional formulas, in terms of fundamental quantities. Is nothing but dimensional equation, right? Let's write here. So every time whenever you want to write dimensional formula, you keep it in mind, you must write in a square bracket. So I am writing here the volume in a square bracket. So here, how much is the mass contribution? There is no mass contribution, means mass power is 0. And what is the length contribution here? The contribution of length is what? 3, and time contribution is 0. So finally, this is the dimension formula. In this, you know, this totally is called, this complete equation is called dimensional equation. Yes. And you know what is this? Yes, you are right. Just now I told that. Yes, you are right. It is dimensional equation. What is that? Dimensional. Sorry. This is called dimensional formula, and this is called dimensional equation. And these powers are called dimensions of the physical quantity. So whose dimensions of the physical quantity here? The volume dimensions. Now tell me, children, why here mass contribution is 0? Because in the volume there is no mass contribution, right? No mass term, right? That is the reason mass power is 0. Why we are having length power 3? Because the volume is expressing the dimensions, isn't it? It is representing parameters. What kind of parameter it involves? The volume is a physical quantity. What kind of parameter it is involved? Length into breadth into height, that kind of parameter, but that related to length. So length contribution is present in the volume. So I think you got it, what is I am telling. Now I'll take one more example. I'll take one more example here. The one more example is, I'll take different way now. The different way is velocity. I will take. What is that? Velocity. Now, if this is a velocity, what is the formula for velocity? The formula for velocity, you know very well, displacement per time. Displacement by time. See, by observing the formula, you can say what is the units, isn't it? Yeah, displacement units are meter per second. Yes, you are right, meter per second. Displacement is meter, and time units are second. So combinedly meter per second is the units for the velocity. Now my intention is to write dimension formula. Now how do you write dimension formula here? The dimension formula easily you can write. Go step by step. What is the step by step? First, what's supposed to do? You must write this is in a square bracket, velocity. So after writing that, what is the thing? By observing the formula, what is the mass contribution? What is the length contribution? What is the time contribution? What are the fundamental physical contribution? You must raise the power. So here no mass contribution, so mass power raised as 0. And any length contribution, yes, we have meter, so mass length contribution is 1. And any time contribution, yes, t power minus 1. So this is the formula for what? This is the formula for what? Yeah, velocity. And this totally called equation, dimension equation. This is called dimension formula, and this powers raised for the fundamental quantities is known as what? Dimensions. Now I'll take one more example. The one more example is, I think you getting clear what I'm explaining. Now let us take acceleration. acceleration. So here acceleration is formula. You see the acceleration formula, velocity, simple formula I am writing, velocity by time. Simple formula I am writing. Simplest formula I am writing, velocity by time. You know velocity in its meter per second and time in its second. So combinedly it will give meter per second square is a units for what? Units for what? Acceleration. Now you have the formula and you have the units also. Now how do you write dimensional equation, dimension formula, and how to express the dimensions? Yeah, look at here. You know, I think you got it how to write acceleration. Acceleration. So now this acceleration, how much is the mass contribution? There is no mass contribution. Then when no mass contribution is present, how much is the power raised in the dimension formula? The power raised in the dimension formula is 0. How much is the length contribution? So how much is the length raised power? The length power is raised by 1. Similar way, how much is the time power is raised? Time power raised by -2. So that time power -2. So this is a way we can express the dimensional formula for acceleration. Children, I will give one more example. That one more example is force. If I take force, simple formula, force is a simple formula. We have a force, a simple formula. Force formula is mass into acceleration. Mass into acceleration. When this is a mass into acceleration, what is the dimension formula? What is the dimension formula? We can write dimension formula. Force you can write here, because don't apply force anywhere. Okay, force here, mass here. See, we have a mass contribution, so m power 1. You know acceleration contribution, acceleration dimension formula, m power 0, l power 1, t power -2. So you will get as l power 1, t power -2. So this is the way we can write a dimension formula for what? Dimension formula for what? The physical quantities. I hope you got it, children. I'll give one more example. The one more example, let us take momentum. One more example. One more example is what? Momentum. So here, momentum also very simple formula. Mass into velocity. Okay, momentum means mass into velocity. So when it is mass into velocity, what is the units? Kg meter per second is the units. Kg meter per second is units. After knowing this value, how do you write the dimension formula? Yes, momentum is equal to, what is that? Momentum is equal to kg means m power 1 we have, and meter means l power we have, and per second means then it will have the power -1. So this is the dimension formula. Here this is a momentum dimension formula. Mass contribution is, power is raised how much? 1. Length raised how much power? 1. Time raised the power -1. This is the way we can express the dimension of physical quantities. Similar manner, even we can express the same dimension formulas for fundamental quantities also. I'll show how it is. See, you know fundamental quantities. First fundamental quantity is mass. So if I take mass, that mass, how do you express mass? Dimension formula as m1 L0 T0, because other other physical quantity powers would be 0, so that it is 0. Similar way, length. Now if I take length dimension formula, you know, length dimension formula m0 L power 1 T power 1. Similar manner, acceleration, time. What is the time? Time is m0 L0. Sorry, I am doing wrong. Here I done wrong. It is T power 0. It is T power 1. Now, other dimension formulas. Other dimension formulas, what? What are the other units? Temperature, if I take temperature, the temperature dimension formula is m0 L0 T power 0 K power 1. Why I added this K here? Because even this temperature also fundamental quantity. So here dimension formula is nothing but expressing all physical quantities in terms of fundamental quantities. But why I am showing only 3? You can show more than 3 also, not a issue. But if you show all the quantities, it is a big gulf. I mean, it is right to very difficult. So to keep it in short, we are writing only 3 or 4. We are taking only 3 or 4 fundamental quantities. Yeah, next temperature. After the temperature, you can take amount of substance. That is m0 L0 T0 mole power 1. So this is your dimension formula, because mole is a unit for amount of substance. Similar manner, what are the remaining things? What are the remaining units? What are the remaining physical quantities? Latter, amount of substance, luminous intensity. You can take luminous intensity. Luminous intensity value is, you can take this way, m0 L0 T0 I power. Luminous intensity you can take CD power 1. This is the way you can express CD. Why CD here? CD is actually candle is a unit for luminous intensity. To represent, I have shown that way. And next, one more unit. We completed length, time, temperature, amount of substance, luminous intensity, current. What is this current dimension formula? m0 L0 T0 I power 1. This is the way you can express dimension formula for fundamental quantities. And last and final physical quantity. Is there any missed term? We completed amount of substance, luminous intensity. Next one is what? Temperature also we completed. See once again. So what are the terms we missed here? Current we completed, luminous intensity, mass, length, time, temperature, amount of substance, current, luminous intensity. All 7 done. Yes, here also mass, length, 1, 2, 3, 4, 5, 6, 7. So totally 7 fundamental quantities completed. So this is what your topic for today. So in the next class we will discuss with other topic. I hope you have understood. Keep practice. Bye bye.